One of the key things in agentic AI is reinforcement learning that you're going to hear again and again. It's one of the type of machine learning models, and the way it works is little bit different. We are not going to the maths of it, but we are going to go in basic foundations that are there, and it really enables agentic AI to learn from interactions. Reinforcement learning is used a lot in autonomous driving and troubleshooting the jet engine. There is an example, if you might have heard about Amazon, the car that is there, the autonomous car that is available is used, and there is a lot of use cases to show you how they have used reinforcement learning to train that self-driving car that is there. And the agents maximize rewards through feedbacks and penalizes for any wrong mistake. And to avoid penalty is the key learning mechanism for these reinforcement learning that is there. And we will be looking into the key concepts that agent takes action in different states. Reward or punishments guide the learning. Maximizing the reward is the key for every object that is there, and learning from experiences improves the decision making. And reinforcement learning is very similar to human behavior reinforcement. Just think about a child. He is trying to learn something, and if the child does something wrong, the parent gives him a small punishment, and just to make sure that the child avoids the punishment, he tries to learn faster and more efficient. A simple example to show you the key concept in reinforcement learning. So there is a learning method that is called Q learning, which is a powerful reinforcement learning method, and it uses something called as a Q table to track the optimal action that is there. And I'm going to show you something like this in the later examples. Like suppose you are a person is here in this particular area. He needs to go to his goal that is there. So if he needs to go to his goal, just this is a very simple scenario, and this is the Q table. Just think about this in such scenario, and this goal is to reach this particular cell. Suppose then for this person there are 4 options for him to go if he has to move in the straight direction, right? Not in the diagonal direction, just in the straight direction. Just an example that I'm giving. Suppose he takes this direction, it means that he is going farther away from the goal, so he is going to get a -1 penalty. And he wants to then he will understand that he does not need to go ahead like this, he needs to go back. But if he goes here, it means it is going towards his goal, so it is getting +1. Similarly, then the next state, if he is here, then if he goes here, then this is how he reaches towards his goal. +1 for going in the correct direction, and -1 for going in the wrong direction. So this is what we are going to talk in the key learning algorithm. The goal is to maximum the reward through a learned action that is there, and continuous updates improves the decision making that is there. So for the Q learning, there are 6 main steps that you need to understand. I just showed you a visual example to make you understand how these things work, but theoretically there are 6 different steps that you need to understand. We'll talk a little bit more about it in details in the next slides. One is developing the environment, identifying the states, defining the actions, that is the choices that the agent can make, establishing reward signals that are there, developing policies, and then defining a value function that is there. So these are the 6 things that are very, very important for all of us to understand, and I will be sharing you the slides, so no need to take stress about that. So one is the environment, the world where the agent operates. This is something very important. It contains the state, action, and rules, and define how agents interact with the surrounding, and policies influence these agentic behavior. And you will see more about response mechanism determines the outcome. So this is the environment that we need to set. Then we need to identify the states. Like state represent different situation. Example, if a camera is detecting darkness, the system must recognize various states, and understanding that the state change is essential, and the state recognition influences the agent action that is there. So this is very important to identify the states that are there. Define the action. Action are responses to the state. Adjusting aperture in the low light is something that is a action if according to the state that we mentioned about the darkness. Jet engines may trigger fire suppressions. This is something that we need to do. Action are must be well defined, and each action has an associated impact that is there. Then establishing the reward. Just think about the simple example that I showed you here, right? So for here, movement, reward is +1 and -1 for the penalty. This is the state. The goal is to reach this particular cell. So these are something, just an example that you want to visually look at it. And encourage desirable agent behavior. Then develop policies that we discussed. Taking the example of the jet engine, the policy that the airline must never shut off the jet engine mid-flight. These are basic rules. A policy ensures consistent decision making, helps in structuring the agent behavior, and guides the decision making in the new state. So this is very, very important. And then this value function is very important, right? Estimates the expected cumulative rewards, help assess long-term benefit, determines optimal action over time, and similar to strategic planning in business, which is very, very crucial for long-term benefits. So value function is very, very important, and always for every learning, continuous learning is very important, and RL agents constantly improve. They tackle complex challenges, and this is a key for agentic evolution that is there. So just to conclude, conceptual understanding is crucial for all these topics. We are not going to the maths of it. It's very complicated, but you get an overall idea how it works. Reinforcement learning integrates into a lot of real world applications that are there. They learn from interactions and feedback. Understanding AI behavior is really valuable, and reinforcement learning really helps create this type of intelligent system. Defining those 6 steps is very important for any reinforcement learning, that if you want to have it successful. Thank you, and learn more in the next videos.
And begin your journey toward AI-enabled excellence. Transform your AI strategy. Transform your leadership. Transform your future.